fuel the future of agriculture. My name is Josh Haslin, Research Director here at Lux Research, and I'll be moderating today's session. I'm joined today by my colleagues Deepesh Bista, who is an analyst for agriculture innovation, and Keith Cannon, who's an analyst focused on digital innovations here at Lux Research. Throughout the webinar, you can type any questions you have in the questions box on your screen, and time permitting, we'll answer all those questions that we can. But if we don't get to your answer today or your question today, please don't hesitate to email it to questions@luxresearchinc.com, and we'll respond. With that, I want to jump into the presentation. To you, Keith.
Thank you, Josh, and thank you for everyone for being here. Throughout this webinar, I'll be focusing on bringing an outside-in perspective on robotics innovation. And I'll start off by level setting on the different use cases and technologies and innovations we see in robotics across different sectors outside of agriculture. After that, I'll pass it over to Deepesh to bring his agriculture-specific knowledge. And then at the end, we'll bring it all together to see what the future holds for robotics in agriculture. Like I said, I want to start off by discussing robotics technologies and level set on the status quo of robotics today. But throughout this presentation, this webinar, I would like everyone to keep in mind a few key points and to be thinking about throughout this webinar. Fundamentally, what we want to hammer home is that the use case versatility is paramount, that robotic solutions need to be able to adapt to more than one use case to make a compelling business case for clients. Additionally, the advent of more software-forward startups and innovations are going to disrupt the agriculture space. And despite the fact that robotics in agriculture is going to be a slow burn, we think software and bringing in new AI, generative AI technologies is going to change the game. Thirdly, we would like everyone to keep in mind that our third key point is not to get stuck on the obvious problems, those with the largest market size, but to look for hidden solutions with these technologies. So keep these 3 points in mind throughout the presentation. We'll bring them back home at the end. To level set on what we mean by robotics, we break it down into the hardware and software components. When we're talking about robotics, we're talking about both of these almost always in tandem. So on the hardware side, we're talking about how it exerts mechanical force, which is the actuator, along with its sensing, which broadly speaking, it includes computer vision, for example, but it includes any sort of detection of physical stimulus. So this includes sniffers and gas detect as well. On the software side, it's broken down logically into the part that analyzes the input, the sense input, the aspects that actually plan out missions, and the aspects that also tell the robot logically how to act in different scenarios. What we see when we look at startups innovating in robotics in different sectors is we see fundamentally the strongest solutions are those that take the right technology and match it to the right problem as defined by that sector specific challenge. So for example, in mining construction, what challenges has it faced historically? Labor shortages, to name a few. Startups like Built Robotics are notable for bringing in software expertise into an area that traditionally has lacked it. And it did so by bringing in autonomous vehicle technology, such as the LiDAR, to a solution, but where it's got a very strong fit. In this case, because mining environments like quarries and construction environments are less tightly regulated than those for passenger vehicles. So it was actually a very strong fit for autonomous vehicles technology, but it matched the sector-specific challenges of mining construction extremely well, and they're doing very well as a company. And they're also broadening out into new sectors as well, including energy and solar farms. It could be said, the same sort of narrative could be said for industrial and manufacturing, the energy sector, and in e-commerce, logistics and warehouses and the like, trying to develop an operating system for manufacturing robots developed by companies like ABB and others. But it matches the strong sector challenge of needing technically skilled data science, AI skilled workers in a manufacturing environment in a sector that that has traditionally struggled to attract such talent. So their goal is to build an operating system for robots, and that matches as a strong sector-specific challenge. E-commerce likewise has been impacted heavily. The COVID and the rise of e-grocery has reignited the lights out warehouse dream. And now there's robotics vendors building specifically for fulfillment of e-grocery and e-commerce. So again, how these technologies are built really reflect very well the challenges that these sectors are facing. Three that stood out to me in particular throughout studying robotics today include, again, as mentioned, these companies like Ready Robotics, Energy Robotics, and Built Robotics. What they really do well is they match those sector-specific challenges. So for example, Energy Robotics, what they're tackling is the need to deploy different kinds of, the need for robots to navigate different kinds of environments. To have asked that, a solution for that question has been, how do we build a general purpose robot? Often a humanoid robot that literally can, work in these different use cases. But what Energy Robotics are doing differently is trying to orchestrate fleets of different kinds of robots. So instead of having one robot do everything, they're working more on the command level of orchestrating fleets of robots. And in complex environments like those that are offshore or pipeline out in the middle of nowhere, that sort of philosophy seems to be working very well. So we've discussed different companies working in different sectors. I would sum it up by pointing to 5 different technology areas as indicated here where companies are looking to innovate. And I organize it according to the ability to sense your environment, software that controls the robot, orchestrate using different kinds of robots like drones or crawlers or quadruped like dogs to achieve different kinds of movement in an environment. Companies are also innovating with a focus on labor safety and efficiency. So for example, having autonomous mobile robots in warehouses that are really resilient to edge cases that could otherwise harm human beings. So in this case, that's a balancing act between safety and efficiency. Researchers and companies are innovating, however, on the level of the form factor and locomotion of the robot. And I think a particularly indicative example is of a research group from Yale who are building a sea turtle that can move just like a land and sea turtle. And so it's an amphibious robot inspired by the biological design. In terms of applying these technologies to specific use cases, we at Lux have developed a tried and true framework of questions to ask oneself when gauging a potential solution to a robotics application. As a preliminary question, we have to ask about precision and accuracy. If it can do its job well and repeatedly is kind of a minimum criteria. But for the purposes of this webinar and what I think Deepesh will hammer home is that scalability and versatility are the robotics in agriculture. Scalability referring to being able to deploy the exact same solution, but throughout the business operations. Whereas versatility is more about scaling in kind, scaling to different cross use cases. So, for example, in agriculture, that might be herbicide and harvesting might be different use cases. But I transform those two a bit, scalability and versatility, and I rename them. And for the purposes of this talk, what I really believe is a key take home is that startups need to be striking this harmony between enabling compelling use cases that are also versatile and that can also be make compelling business propositions. Fundamentally, what we hear very often from startup CEOs building in the robotic space is that a key blocker for them growing as companies is the need to convince customers that they do have a compelling business case by delivering ROI and enabling more different use cases, which we call versatility here. And one thing that Deepesh and I will discuss later on is how companies are overcoming these challenges of higher upfront CapEx and lower recurring revenue, which has traditionally stifled robotics innovation. Now I'm going to pass it over to Deepesh to dive a bit deeper into the agriculture specific.
Thank you, Keith, for laying a great foundation there. So in this section of webinar, I'll be talking about what are the drivers for advancement in agrobotics, followed by a few case studies that kind of shows what players are, impacting the space. As Keith mentioned, the two key issues across other sectors, mining or industrial, is that like the use case, the versatility, and then the business model is key challenges for robotics implementation. And I think agriculture is also in the same path. Like a lot of these innovators have the same issues. So, but having said that, agriculture is already in the path of mechanization. So if you look at it, farmers, even with the small land holding, they're already using power equipments in their day-to-day farm activities. So, and with robotics advancement, it's already making its route to the farmer's field. But and the solutions that are there right now are more very hyper specific to a particular task. It could be either taking care of the weed, or identifying a fruit that's ripe and just to harvest and things like that. So it's a very hyper specific and very high cost solution for the time being. But having said that, the drivers for agrobotics are basically categorized into three different sections. And in the last 10 years or so, it has gained a lot of momentum. But these three reasons: the rising cost of inputs, reducing labor force in the agriculture sector, followed by tech alignment, the advancement in computer vision, machine learning, and AI, which Keith kind of touched upon, as well as finding these solutions for high value crops have become more prevalent in agriculture, driving this space further. So according to the USDA data, in the last 70 years or so, agriculture sector has seen 73% of decrease in family farm workers, whereas 52% of the hired farm workers have declined in the last 50 to 60 years. And the trend is still continuing in the ag space. And with this followed by the rising cost of minimum wage and other regulations, providing the healthcare for the farm workers, immigration issues and all that, have kind of created a dearth for farm workers in the agriculture field. But if you look at why robotics is gaining momentum, other than your labor workforce, is basically also the specialty crop angle to it. If you look at the top hand graph, it shows that your high value crops, like your fruit, nuts, or vegetable, in a farm that's 1,000 acres or more, you need 100,000 man hour or plus to do that work, compared to your corn, soybean, and wheat. Even the 2,000 plus acre farm need around 2,500 man hours. And this is the reason for this is basically the one that I talked about, the mechanization in agriculture. And a lot of the farmers already have tractors or in kind of machineries in their farm, and that's why the row crops already are kind of semi-mechanized or mechanized, and that's why the opportunity for robotics is more on specialty or high-value crops. This here I'm going to talk about the landscape of agrobotics. So this is from our report that we published a month and a half ago, where we kind of divided agrobotics into weeding, harvesting, monitoring, and moving. And if you look at it, and the theme is one size doesn't fit all for agrobotics. And in the past 10 years or so, robotics has seen a lot of mergers and acquisitions, as well as collaboration, even with the big players, small players, OEMs, and that is turning into a very strong generalizable business model, as well as very versatile use case in this space. So trying to summarize these M&As in the last 5 or 7 years, what's happening in the space of agrobotics. So, robotic platform basically that's focused more on like weeding or like, overall crop protection has gained a lot of commercial momentum. But having said that, if you look at this is the non-exhaustive list. So if you look at it, since the September of 2017 was when like John Deere acquired Blue River Technology. Blue River Technology is a see and spray, has a see and spray capabilities for taking care of the weed. And then like in September of 2020, Corteva, your input company, partnered with MBAC for like your Simpas technology. And then not only with like, OEMs or like your input players, you can see in September 2021, this M&A was continued within the indoor agriculture world as well, where Priva and Octinian kind of merged their robotic platform for better serving the growers. And then like, if you see bio-based partnered with EcoAsian for like, better autonomous crop monitoring. And I mean, we all know BioBest is one of the leader in alternative crop protection. And in November 2021, Raven Industries was acquired by CNH. And then in the March of this year, like CNH acquired Argumenta for over $110 million to bolster its precision ag capability. And this year, in July of 2023, John Deere acquired Smart Apply, a company based out of Indianapolis, and that's focused more on precision application for your high value crops like orchards and vineyards. So you see where John Deere is trying to cover his ground, may it be like your row crops from the likes of acquiring Blue River Technology, or like, acquiring Smart Apply for high value crops. And this trend will likely to continue in the coming years as robotics gain even more momentum. So I just want to take a little bit of time and talk about this particular slide here. So this is from our analysis of our robotics report that we published earlier. So if you look at it, like we dissected 30 plus companies that are excelling in the space of agrobotics in terms of company momentum and technology impact. So if you look at the top right hand quadrant, that's then you see a lot of like, weeding companies that are there with that. That's showing that like, the current focus of this space is more on like weeding solutions. But if you look at this graph in detail, then you can see that companies that have like multiple use cases, which Keith talked upon, like is one of the bigger challenge across robotics, is like they are also like have a high company momentum and higher technology impact, and the likes of Naya Technology, Verdant Robotics, Solintech, and these are carbon robotics. These are like these have like high company momentum and high technology impact because they're trying, they're aiming for multiple use case scenario. So now I want to give few examples of companies with a case study that have shown their multiple use case scenario and shown they can excel in this agriculture robotic space. So Solintech is a company based out of Brazil, and they recently launched their Solix platform, which is solar powered autonomous sensor technology that optimizes the field. So when I say optimizes the field, I basically mean like this machine can do multiple of things for farmers in the field. So first, it's solar powered, which is great. But what it does is basically it scouts the farm, and not only it scouts the farm, it also sprays at the millimeter level accuracy to take care of the weed. And then it also controls the pest during the nighttime with a special light attachment that's there, and gathers various data. So while this company Solintech continues to innovate in the space of overall agrobotics and digital agriculture, it's also partnering with various cooperatives, and that's one way for them to penetrate the North American farmers. And it also has like customers across 11 countries, and they have over 12 million acres of land. So I see them suited for like, penetrating a bigger farmer down the road with their all-in-one platform. And just to add something to this is like, if I'm a farmer, I'm not going to I'll be thinking twice if I wanted to buy something that does one job and sits around 10 months out of 12 months. For example, if I just buy a weeding robotic equipment, then if it's just worked for 2 months out of the 12 and just sits for 10 months, I will think twice to buy before before using the equipment. So, but what Solix has done is like, it has tried to find a machine that kind of like helps farm in multiple operations and make farmers' life easy. Similarly, this is another case study from Verdant Robotics. So Verdant Robotics is a company based out of California here, and they have this dual threat robot that kills the weed as well as fertilizes the plant simultaneously. So the company claims that like they can identify and treat over 500,000 plants per hour, which is equivalent to like 4.2 acres per hour of the speed, and also claims 95% of the less chemicals being used by their machine. So what Verdant is trying to do is like, it's trying to give farmers this option of like, not just only killing the weed, but also spraying for the fertilizer, as well as now they're also simultaneously working on the same machine to work as artificial pollination in the apple orchard, so that farmers have this ability to thin the apple orchard for like bigger and better apples that can fetch higher price for them. So having said that, like what I wanted to say is like, companies like Verdant Robotics or Solintech are targeting multiple use case and have found a way to gain farmers' trust and like penetrate farmers' field. With that, I would like to pass it on to Keith for the next section of the webinar.
Thanks, Deepesh. For now, what we'd like to post some questions to Deepesh and kind of discuss a little bit what we've been talking about. And namely, I think the key question to be asking is, will robotics really rise up to agriculture's challenges? From my perspective, from other sectors, as I mentioned before in the beginning, what you see is a lot of thought going into how technologies can be used to really fit into the narrative of the drivers of those sectors. And so that's something I'd like to discuss with you, Deepesh, as actually right now. From what you've seen from robotics players in agriculture, how are they navigating the historic challenge of having this higher upfront capex, longer time to ROI, seasonality, and finding ways to scrap up some recurring revenue from their customers? How are they addressing that?
So first and foremost, Keith, like this is a very robotics is a very what do you say, a growing early stage field in agriculture, right? And a lot of these companies are trying to establish themselves, and it's a very capital intensive business as well. So a lot of these companies, the way they're trying to tackle the issues with the ROI and all that is like, they're trying to come up with this business model that's kind of get them there, that's kind of get their one foot on the farmer's field, and kind of show their like technology impact on the farmer's field. So I'll again give an example of Verdant Robotics. So Verdant Robotics started their solution basically focused on taking care of the weed. And what they did was like, they basically focused on the carrot farmers or carrot field and trying to tackle the weed problem in carrot farmers. And they did show a lot of progress in that test period. And now they have like over 50% of the carrot growers in California binding contract as a customer for them to move forward to their next stage. So that's something, I mean, it's absolutely fine and okay to just have one product or one crop, but do good at it and show that it works. That's one way like Verdant is trying to gain success. And like that's one way I think companies should focus in early stage of their start.
That makes a lot of sense. I'd also like to discuss whether or not herbicide is the right problem and how we can generalize use cases, the issue of long buying cycles, and the need for supporting infrastructure and regulatory drivers. But before we get to the rest of those, I would like to ask, do you think herbicide is the right problem to be tackling? I mean, I know it's one of the bigger problems, but do you think that there might be an issue that could be lower hanging fruit for startups to try to tackle or for customers to try to solve?
At the moment, yes, absolutely. Herbicide is the right problem to tackle. I'll give an example. So overall crop protection market is more than $60 to $65 billion, right? But herbicide is like $27 billion. So yes, there is money to be made, addressing this weed resistant challenge. So what I'm saying is like, there is an opportunity, but there is also problems in the farmer's field. And a lot of these companies are seeing both the things at the same time, because I mean, weed resistance is a big issue in the field for farmers, and that contributes to bigger yield loss for farmers. So that's why a lot of these startups are focusing on like herbicide. I think it's the right one, but if you ask me, the second best would be like basically going for the harvesting technology.
Right. That makes a lot of sense. So yeah, the reason I think I asked that is because something that I've learned from the energy sector is that they've tried a number of different robotics use cases, but one that they actually found surprisingly compelling was just autonomous vehicles to help transport tools, just to make workers' jobs more efficient, which was not for them the most obvious solution to try to tackle it all. So that's why I ask. Where would you say, which companies have done the best job at generalizing use cases? You've said that you've seen some companies do well just by tackling one, but how do you see them? Who's done the best at tackling multiple use cases? Who's the leader in that, and what did they do right?
I mean, I personally see Solintech being like the company that's targeting multiple use case, and I mean, like companies like the likes of Robotics, Nio Technology had fleet of robot that kind of tackles different function in the farm, and also there's this company from Australia called Swamp Farm Robotics that's also trying to work on different use case in the farm. But for the time being, what we have seen in the field, the results and all that, I feel like Solintech is kind of leading in the space of tackling multiple use case.
Yeah, absolutely. That makes a lot of sense. Yeah, so and we've also spoken to founders who've told us. Go ahead.
So, I mean, you've heard like what's happening within the agriculture, like you laid out a good foundation for what's happening across the other space. Do you see that agriculture with what's happening in the other field, other space within the robotics? Do you see that agriculture will drive success from robotics within few years or not?
Within a few years, I think is the tricky part of the question. In the long run, I'm very optimistic. There are some drivers in other sectors that give it a little bit more tailwind. So for example, the energy sector has greenhouse gas emissions detections regulation. That's a major driver for using monitoring and inspection robots. However, I think just the broader developments, I've spoken with a lot of startups. We've spoken with startups who've told us that basically the vast majority of their engineers now are software in data science or in AI. And I see that as being not only one of the driving factors in addressing the versatility challenge, but also the business model challenge. So a separate startup I know has told us that they're able to offer different levels of autonomy for their robots' missions, and that discriminate and have a more appealing business model for different farmers who can afford different levels of autonomy as well. And so I think the developments in software more broadly are going to enable both the versatility issue to become a little bit less pressing and enable different kinds of business models as well. Something to further back that up is that we've spoken to, I know you know, startup founders who've told us that their vision is that artificial intelligence will be able to adapt, not just on a daily or weekly basis, but over the course of years and decades, in fact, to create a tremendous amount of stickiness with vendors who have intelligent systems that intimately know your farm and very intimately can make recommendations and optimizations. And so that's another thing to consider, is that what's the software industry is relied on is this kind of stickiness and learning an individual's taste. That's what makes streaming services or social media accounts. And the same thing could be happening in robotics in the long run.
Got it.
Do you see, I mentioned briefly regulation. Do you see any positive regulatory drivers? I mean, I know maybe minimum wage might be one, anything related to sustainability?
I mean, when it comes to regulation, it's kind of like boiled down to like whether a solution provider has this completely autonomous solution for the farmers field, right? In many parts of the country, in many parts of the world, especially in the European region, the regulations are like if an autonomous robot is working in a farmer's field along with the farmer, it should not be, harming the farmer. So that those are the things that could be a regulatory hurdle, or but when it comes to like the drivers, regulatory drivers, I feel like use of lesser pesticide or lesser inputs is one that's kind of like favoring the agrobotics, because overall these solution providers claim that like they use less less of the input and do the job better, even better than applying the traditional way. So
Yeah, absolutely. So then all in all, who would benefit most in say 5 years or 10 years from a heavier presence of robotics in agriculture? Who really wins from that?
I think farmers benefits the most, to be very honest, because if these solutions do their job, and if these solutions are like functioning well, I think farmers will be able to increase their yield, and that kind of that will help them do better. And but like not only that, like a lot of these solutions are like very eco-friendly in the sense like and they have a less impact on the ecosystem. So I mean, environment wins, and and at the end of the day, if they're doing well, these solution providers are. That means like their technology working, and I feel like even the technology provider wins as well. But at the end of the day, it's the farmers that benefits the most.
Interesting. Actually, one thing I wanted to talk about before we give some concluding remarks is. One thing that we've seen as an issue is supporting infrastructure. Do you think that, do you think this is a good example of something that some customers have experienced as an unforeseen issue, is not being able to support robotics solutions with their existing infrastructure? And do you see that as being a limitation? Do you see that as being maybe a hidden cost in some of these solutions?
Absolutely, yes. So this is something like we don't talk a lot about the infrastructure, and I think if the way I see this, if it's a pyramid, that's like the base of the pyramid, we should have that infrastructure. So we talk about all these solution provider, like, gathering data and and then like providing that and recommend it to the farmers. But let's say a farmer in the Midwest where there's no like connection or anything established in their field, how the data be connected to the server, and then like that can be given as input to them. So I mean, I think the infrastructures has to be there.
Interesting. Yeah. Okay, great. No, thanks for those thoughts, Tipesh. I think we'd like to kind of just recap this discussion with a few key takeaways that reiterate the takeaways that we started off in the beginning. Again, I think one of the main takeaways was just regarding in on what the problem is to be solved and how well that technology actually addresses that solution. Is there a very compelling narrative for how that technology is really meeting one of the key drivers of the agriculture sector? I think is something worth asking, because that's how we see solutions succeed in other sectors from my outsider perspective. Again, what commonality is that at a bare minimum, at some point, they need to be able to generate that versatility that we talked about. I know that also, Deepesh, we've discussed a lot, just whether or not agriculture is kind of up to speed in terms of developments in other sectors. And what I do think is worth paying attention to is developments in edge and AI capabilities, and how that's going to influence all robotics, including those that in agriculture. And I do think that one of the key reasons to pay attention to these technologies is because of the business model changes that it will have. Namely, as I mentioned, offering different features, and for example, the stickiness that comes from having one vendor have your data and having been trained on your farm over years. And I know that you and I also discussed quite a lot today, Deepesh. The third key takeaway on the cost of these inputs and how the magnitude of these problems you're getting everyone's attention, especially from robotics vendors as well. But again, we also want to point towards issues, like we said, supporting infrastructure to make sure that there's not some hidden cost there that is unforeseen. So I would highlight those three as key takeaways to kind of bring it all home. But thanks so much for all your thoughts, Deepesh, and Josh, handing it back to you.
Yeah, thanks, guys. And just to reiterate, what we're going to be doing now for the remainder of the webinar is take a few questions for you both. Remember, I just want to remind everybody that you can type your questions into the Q&A box. It should be in your lower right area of the webinar area. And we'll be doing that probably for about 10 minutes or so. So you have some time to think and place those in. But for now, we've had some questions come in, guys. And I think the biggest one that we have coming in is really around continuing discussion on leading challenges for adoption. And I think the way to phrase this, building on the question we've had submitted, is you guys have already talked about a lot of challenges. You've talked about infrastructure, you've talked about scalability, versatility, those types of things. But I'm curious, on top of that, for the companies that have not succeeded, are there any things that come out for those companies in particular as big red flags, right? For folks to say, what is likely to pressure adoption of that particular technology platform? And I'll put this both of you, because I think an outside-in perspective for robotics in general, and those focus more on ag-specific use cases is really important. So let's start with Deepesh for the ag-specific piece. We'll come back to you for a more general.
Sure, that's a great question. And that's something I think it haunts all the technology provider all the time. Like, how do we get to farmers more, right? So, we talked about the versatility. We talked about, scalability and all that aspect. But one thing I see it is like, oftentimes these technologies are like very expensive in the sense like, farmers don't see it as like it's a right thing for them to do. I already mentioned earlier in the talk that like, why would I want to buy a harvester or like a weeding machine that only works 2 or 3 months out of the 12 months and pay almost $500,000 or upward of $500,000 fee just to have it in my field, right? And then another thing is like, if I'm a farmer, I'm doing few crops, no matter what. And like the diversity in the farm is so much that like, maybe, like if I just, for example, if I just buy an apple harvester, like then I won't be able to use that for my strawberries or blueberries and things like that. So that's again, talking about versatility, but in a different way. And last but not least, and what I see it is like the education, Josh. Like, I mean, farmers really are not aware about how to use this, why these technology make their life better. And, there's not much of like, I would say, education or extension in the agriculture world to talk about like robotics.
The last point's really great, Deepesh. Obviously extension's important, but lacking in a lot of cases to bolster technology, show how it's used, show how it's valuable. And that's all on the grower, or it's on the tech developer now, right, to demonstrate that in a world where, as you guys both said, we kind of have a slow burn. There is a burn happening for this technology, but each solution, each fit is really tough, and building that together can be really tough. Keith, what about you as far as generalizing some of your knowledge on robotics? What really stops something from getting adopted?
Yeah, I would. So we've talked a lot already about cost and versatility. And I implicated in that, but still slightly different, is actually ROI. What I've learned from specifically users in like the energy sector is upfront cost that, a customized solution is going to be expensive, like 7 figures or more. But actually, even the ROI itself is actually not even that compelling. So it's a bit of a double-edged sword of high upfront expense, customizability, a lot of time, and then the ROI itself is not even that compelling, which I think is why Deepesh and I have hammered home so much the versatility issue. I've spoken to a robotics investor who really believes that robotics is equal parts software, equal parts hardware, and I think are actually shifting that even further and saying that robotics is like more of a software problem than hardware problem. A lot of the robotics providers I see who kind of got stuck in their development in other sectors are they're not really scaling startups. They kind of got stuck as small businesses, and I think that's because they did not really take the successful philosophy from the Silicon Valley growth startup type of being able to cases faster. And so they get kind of stuck in a realm of being super niche, and they don't grow very much. So I would say the philosophy change that software is becoming more obviously a key ingredient or the key ingredient is going to change. Why now? The question we've been asking today is, why is now different for robotics and agriculture? Because robotics has always gone through these ebbs and flows, always gone up and down. If you look at the why now is a good time to be asking about robotics. And I think it's largely because of the philosophy change of bringing in software faster, earlier, and seeing themselves more as software companies.
Yeah, totally. And we've had some follow-up questions come into that, which which include, the idea of, what are the drivers today, and why are they so important, and thinking about those drivers and what the offers are. So, okay, we have, things like undocumented labor coming forward was something brought up. And if you tie that to, application herbicides, you have a hard barrier to overcome, right? When those things are happening. And until policy, right, comes in and really hamstrings those growers with respect to that. And that is happening, right? That's one of the main things I think we've seen, whether it's the EU, whether it's the US, there are policies moving forward that are being more stringent on, we'll call it immigration within a nation. And that is indeed causing some more interest, right, in these technologies themselves. So I totally agree with what you both are saying, and I do think it aligns. Now, switching gears, we have time for one more question, and you guys touched on this a little bit when you brought up what are some of the other use cases out there. So we're focused on herbicides, things like that, right? So you need your primary use case, from what I heard, and it needs to get you using that instrument often. But on top of that, right, there are other needs in a field or in any other industry. And I think you kind of brought up things like sustainability, and obviously, that's important. What about even in areas outside of robotics? We have some interest, for instance, in things like animal agriculture. Do you guys see any potential options for, again, we were thinking about this webinar and how robotics across could benefit from this really challenging use case of agriculture, right? Here's a really tough place to make a robot for. Do you guys see any options maybe for extending these solutions to other industries? And let's start maybe with animal agriculture. Are there robots that you think could work in those areas, and maybe even others? Will this advancement in agrobotics affect other industries? And so, Keith, I'm going to start with you this time on just thinking about, are there other places where you think these types of technologies are going to have purchase as well as perhaps software enables versatility?
Yeah, that's a good question. I think hidden behind that is asking whether or not developments in agriculture robotics as those we see in other areas. I see that as a bit tricky. I think one area that, at a very minimum could have a lot of impact is AI-enabled sensing, for sure. I mean, so for example, the challenge of identifying fruit that aren't exactly homogeneous, right, aren't exactly identical. I think that's something I've seen people develop sort of bespoke, cutting edge, for instance, computer vision solutions for developing computer vision that is low power on the edge that can identify different kinds of fruits. Or the same fruit, but with the nuances of being out in the wild. And so I think computer vision, as an example of AI-enabled sensing, is where historically, anyways, and today, some robotics agriculture is actually cutting edge, and that's something that there will be absolutely a transplant from that to other sectors as well.
Cool.
But I do know that yeah, I'll leave it at that.
Great. And not to cut you off, we're running short on time. I just want to make sure the final comment here back to Deepesh. Deepesh, outside of field ag, where do we see it? Let's think primarily maybe for even animal agriculture. Are there opportunities, do you think, for robotics to begin to enter that space and impact those industries as well?
Yeah, I mean, if you look at it, robotics has been used for milking and the cattle farms and all that. That's been there, right? But even use of robotics for herd management would be another great area of opportunity, But one example I wanted to bring within ag, but it's a different use case, is within genetics. It sounds very different, but there are companies that are working, incorporating this robotic platform for breeding better crops, and then the way they're doing is getting more phenotypic data and all that, and they're trying to breed better crops using robotics. So that's something very unique angle to ag robotics.
I think that's a great place to end on, right? Thinking about robotics and thinking about those different use cases, and that's particularly for even ones we already have, drones, et cetera. So it's a good place to end, a good place for some creativity out there to think about robotics and begin thinking about novel use cases for that in the future. But that concludes our webinar for today. Just as a reminder, the slide presentation is going to be available to all attendees. It'll be sent via email today. After leaving the webinar, you're going to be prompted to complete a survey on today's presentation. So please do complete that. It really helps inform us on how to improve our webinars in the future for you all. And then also lastly, please do take a moment to check out our upcoming webinars. And again, thanks for joining us today. Have a great day. Thanks all.